Previously, we have learned on center of symmetry, or also known as center of inversion, followed by plane of symmetry. I really hope that you try to draw a simple cube and identify the 9 plane of symmetry on your own. Next, we are going to learn on axis of symmetry and rotation. This is an axis passing through the crystal such that if the crystal is rotated around it through some angle, the crystal remains invariant. The axis is called n-fold axis if the angle of rotation is 360 divided by n. If equivalent configuration occurs after rotation of 180, 120, and 90 degree, the axis of rotation are known as two-fold, three-fold, and four-fold axis of symmetry. How do we get that? 360 divided by 180 degree, that will give you two-fold. 360 divided by 120 degree, that will give you three-fold. And 360 degree divided by 90 degree, that will give you four-fold axis of symmetry. For instance, if a cube is rotated through 90 degree about an axis normal to one of its face and its midpoint, it brings the cube into self-coincidence position. Hence, during one complete rotation about the axis, which is 360 degree for one complete rotation, at 4 position, the cube is coincident with its original position because you can rotate 90, 90, 90, and final 90. That will give you total of 360 degree. Such an axis is called four-fold axis of symmetry or tetrad axis. If n equals to 1, that means the crystal has to be rotated at 360 degree, and this is what we call identity axis. Each crystal possesses an infinite number of such axes. When we have n equals to 2, that means the crystal has to be rotated through an angle of 180 degree. And this is what we call dyad axis. Since there are 12 such edges in a cube, the number of dyad axes is 6. If we have n equals to 3, that means the rotation angle is 120 degree. And this is we call triad axis. In a cube, the axis passing through a solid diagonals act as triad axis. Since there are 4 solid diagonal in a cube, so we have 4 triad axes. And finally, if n equals to 4, as we seen earlier, so the crystal has to be rotated at 90 degree, and this is what we call tetrad axis. It is discussed already that a cube has 3 tetrad axes. And if we have n equals to 6, the corresponding angle of rotation is 60. 360 divided by 60 degree, then that will give you n equals to 6 or 6-fold. This is what we call hexad axis. A cubic crystal does not possess any hexad axis. If you notice, we only have n equals to 1, 2, 3, 4, and 6. What happened to 5? Crystalline does not show 5-fold axis of symmetry or any other symmetry axis higher than 6. So we only have n equals to 1, 2, 3, 4, and 6-fold axis symmetry. Okay? Identical repetition of an unit can take place only when we consider n equals to 1, 2, 3, 4, and 6 full axis. Okay, let's learn how to draw the rotation. So first of all, you have to draw this big circle. This big circle can be a solid line or a dotted line like this. Doesn't matter. Okay. Next, you have to draw the symbols. We have learned earlier previously in the lecture, for rotation, there are different symbols with different meaning. I hope you still remember. So for n equals to 1, we use dot. N equals to 2, we use ellipse. Okay, then n equals to 3, we have a triangle. Then we have a square here for n equals to 4. And finally, we have hexagon here when n equals to 6. Please draw the correct symbol to represent the number of fold given. So normally, we will just give you the number of fold and you have to calculate the angle of rotation and draw the illustration. So as we said earlier, the first step is to draw the big circle and then draw the symbols. Then you have to draw a small circle outside the symbol. And please indicate which direction is the angle rotated. Normally, we rotate it in anti-clockwise. So this is anti-clockwise here. So let's say this is the original motif, or you can imagine this is the motif. Okay, we use a comma in this example because it's easier to draw. So let's imagine this is the head of the comma and this is the tail. Okay, so when you have n equals to 1, that means it's one turn of 360 degrees. So you have to make sure it start here and it has to end here because it rotates at 360 anti-clockwise. Okay, so if you try to rotate this one 360 degrees, so you have to go one complete round and it will come back to this point. Okay, done. That is n equals to 1. Then if you have n equals to 2, that means there's 2 turns of 180 rotation. Okay, so let's try. So this is the head of the comma, this is the tail. So you have to rotate anti-clockwise. So now the head is pointing upward. So this is your rotated motif. This is the original motif. Shall we do it again? So this is the head of the comma and this is the tail. So now you have to rotate 180 degrees. So now the head pointing upwards here, like what we have here. Okay, but remember to draw a rotation, first draw the big circle. Please use something which is very round, okay, a nice round shape. Don't do hand draw. Okay, please use your projector or you can use anything which is have a circle shape. Okay, proper circle. Draw a proper circle. It can be dotted or it can be a solid line. Then second, to draw the symbol. Then you draw a small circle here and make sure you indicate the anti-clockwise direction. Okay, then you draw your original motif here and you rotate 180 degree anti-clockwise, you will get here. Okay, got it. Let's try on n equals to 3 or 3 folds. Okay, first draw the big circle and then draw the symbol for 3 fold and the small circle followed by anti-clockwise direction. Okay, let's say this is your original motif. Now n equals to 3, that means there should be 3 turns of 120 degree. Okay, so that in total you have 360 degree. Make sure where you start is where you end. Okay, so this is the original. So you rotate 120 degree, you will get here, and rotate another 120 degree, you will get here. And if you rotate this one, you will get back to this point. Okay, you can try that on your own. And then when we have n equals to 4, that means the degree of rotation is 90 degree. Okay, so you have your motif here, your big circle, symbol, and small circle, and then the direction of rotation anti-clockwise. Okay, so this is your starting point. You rotate 90 degree, you got This is the first rotation, and then you rotate another 90 degree, you'll get here, and then rotate another 90 degree, and finally if you rotate 90 degree, you will get to the starting point. Okay, the same goes with n equals to 6. Okay, for n equals to 6, that means there are 6 turns of 60-degree rotation. Okay, the higher the number of rotation, the smaller the angle of rotation. Okay, so make sure you use your compass and projector to draw all this illustration so that it will look exactly at the perfect angle of 60 degree for this one, and then this one is 90 degree. Okay, so please draw carefully. Okay, so that's all on how to draw the illustration of rotation. I hope you will practice how to draw this. It's really, really important. Okay, you need to draw this before we learn into detail about the illustration. Later on, you will have roto inversion. Before we go to roto inversion, you have to master how to draw rotation first. Okay, please practice. This is just an example of symmetrical axis of cube. Okay, don't worry about this. Alright, finally, this is the summary of symmetrical elements of cube. Okay, cube is very simple crystal, so that's why we always refer to cube. Even for cube, there are a lot of symmetry elements in a cube. As we said, crystal can have only one center of symmetry. It can have many planes of symmetry or axis of symmetry, but crystal can only have one center of symmetry. Okay, for cube, there are 9 planes of symmetry. If you remember, just now we learned there are 3 parallel plane of symmetry and 6 diagonal plane of symmetry on a simple cube. Then we have dyad axis. We have 6 dyad axis, 4 triad axis, and 3 tetrad axis. So in total, there are 23 symmetry elements for cube. Okay, so that's all for now. We will take a break and continue in a bit.